All right, so let's say we have this guy standing in a car, roller skates on, and this car is traveling at a velocity and it accelerates. And this acceleration by the car causes the guy on roller skates to pick up a velocity going in the backwards direction. Why does this person in the car move backwards when the car accelerates? Now, this seems intuitive, but if we remember Newton's first law, it states that an object acted upon by no net external force has a constant velocity and zero acceleration. And if we look at our situation, the guy in the car is not acted upon by any net external force, so his velocity should be constant. So what does this mean? Is Newton's first law wrong? And the answer is obviously Newton's first law is not wrong. It's just we have to remember that Newton's first law is only valid in inertial frames of reference. But what does this mean exactly? So if we go back to our situation here, and I just want to note an inertial frame of reference is any frame of reference that's not accelerating. If we look at the situation here, we have three possible frames of reference. We have the Earth, we have the vehicle, and then we have the person in the vehicle. We can know that the bus is accelerating with respect to the Earth, so therefore it's not a suitable frame of reference, which means Newton's first law will not hold in the frame of reference of the vehicle. Also, the passenger's velocity is changing with respect to the vehicle, and the vehicle is not an inertial frame of reference, so that's why Newton's first law doesn't hold in this situation. So how can we actually define an inertial frame of reference? We can strictly define it as any frame of reference that is not accelerating, and so this is why the car is not a suitable frame of reference. A perfect example of inertial frame of reference is the Earth, because it's not accelerating. To find this more generally, any frame of reference can be inertial if it follows this criteria. So we can define A as the inertial frame of reference, B as our second frame of reference that we want to make inertial. So if we remember our relative velocity relation here, and we just pick the point P as a point with constant velocity equal to Vp/A, where P/A is the velocity of P with respect to A. And remember, A is our inertial frame of reference. We could say it's like the Earth, for example. And if we relate this back to our example, the point P would be the guy in the car and A would still be the Earth. But P also has a velocity with respect to B, which can be expressed as this expression below. So P with respect to B is like what we had in our situation. It's the velocity of the guy with respect to the car, and we can see that that velocity was moving backwards. So the way to make B's frame of reference inertial is by making VBA constant in both frames of reference. So if we look at our expression, if VBA is constant in both expressions, the magnitude of Vp/A and Vp/B is going to be the same. They might just see it in different directions. So therefore, they're both inertial frames of reference.